In this video, we're going to talk about merge sort. The idea of merge sort is to be able to combine two sorted arrays. So if we have single numbers, like let's say 8 and 16, if they're single numbers in an array, only one element, then we consider them already sorted. If that's the case, if we want to combine these, we will first check both of them and compare them, whichever is smaller. In this case, it's 8. So when we're combining, we will add 8 first. This will be the first element. And now we have no other element after 8. That means we're going to go here and we're going to add 16. And after that, we have no other element after 16, which means that we're done here. We combined these two sorted arrays in one single sorted array. Okay, this. And let's say we have another number like 7. And now we want to combine these three of them. What we would do is check the first element of this array and compare them. 7 is smaller, so we'll write 7. And now we're going to check the first element of this one because we're still here. This one doesn't move. We already used 7, so we can get rid of that. This will move to the next element, but there isn't any. So now we're going to add whatever is in the left array. Because it's already sorted, I don't have to worry about minimum or finding the minimum. 8 and 16. And now we have another sorted array. So this is basically merge sort. I'm just starting from the bottom here. So now I have another array that contains 4, 9, 13, and 22. As you can see, it's also sorted. So we're going to do the same thing that we just did. Here, the smallest one is 4. Now we're going to move here, move to the next element. The smallest is 7. The next one will be 7. We're done with this. Here, we're comparing 9 and 8. Maybe 8. And we're done with this. We're comparing 9 and 16. It's gonna be 9. Comparing 13 and 16. It's gonna be 13. And now we're comparing 22 and 16. It's gonna be 22. Sorry. It's gonna be 16. And now we have no element left here, which means that we can add up every element that is left on the right side. That is only 22 at this moment. So this is the complete sorted array. If, let's say, we were given the same array with numbers but not sorted, let's say it's like 7, 8, 13, 2, 16, what else is left? 4, and 9. So let's say this is the array that is given. How do we turn this into a sorted array using merge sort? Well, we're going to do the same thing, but opposite. So now we're going to divide this into two arrays. So we can divide it right here. This would be about the middle. So now we have 7, 8, 13, and 22, 16, 4, and 9 to be another array. These are two arrays we have. And now we can divide these into two as well, which will give us 7 as an array, 8, 13 as an array, 20, 22, 16 in an array, and 4, 9 in an array. These are like this. And so if we do this one more time, so we can't divide 7, it's already single, we can divide these. At the end, it will give us 7, 8, 13, 22, 4, and 9 as individual arrays, like this. Because there is only one number, it's already sorted. Now we can start to compare them, and if we keep doing that, if just like we explained above, like 8 and 16 right here, we can combine these 8 and 13 because 8 is smaller than 13. This is going to be 1, and again, just like we explained right here, 8 and 16 and 7. Now we can do it the same thing here. So 7 is here. We combine them into an array. It becomes 7, 8, and 13. And we keep doing this for both sides, all of them. We keep doing this, and at the end, we will get to the same conclusion. We will get to the same sorted array that we got here, just like that. Actually, let's just go through it. So 16 and 22, 16 is smaller, so it's going to be 16, 22. And then 4 and 9 is going to be 4 and 9. This right here, the same logic. We start looking at the first elements of both. And so it's going to be 4, and then we got rid of 4. We're going to look at 9 and 16. It's going to be 9. And now we can, because we don't have any more element, we can just add whatever elements are here because they're already sorted. 22. And now we're going to combine both of these just to prove you guys that we will achieve this sorted array. So we're going to compare 4 and 7. We're going to write 4. We're going to compare 7 and 9. It's going to be 7. And then it's going to be 8 and 9. It's going to be 8. And then we're going to compare 9 and 13, it's going to be 9. And then 13 and 16 is going to be 13. But because we don't have any more elements, we can add 16 and 20, and then we're going to get to that result. Now let's take a look at the time complexity of this algorithm. Time complexity of this algorithm will be O log n. So how many times are we doing this? We're doing this operation log n times, log 2 base n times. And how do we know that? Let's say we have 8 elements. You divide that into 4 like this. You divide 4 into 2. You divide into 1. So how many times are you dividing? You're dividing 1 here and here. You're dividing 3 times. So it's 2 to 3 equals 8. We're dividing it 3 times. This 3 comes from log 2 of n being the number of elements in the set. So log 2 of 8. And so now let's go back to the first. Let's go back to the first things we did, which was to combine these sorted arrays. So what is the time complexity of this, the combination? Well, it's basically we have n elements here. Let's assume we have n elements here and m elements here. So it would be of n plus m. And if we assume that the n is approximately the same as m, we can say that the time complexity of the first part of merge sort is O of n. And so we have O of n, and we have O of log, right here we have O of log 2 base 2 of n. So as a result, my time complexity will be O log 2 of n times n, right? Because I have O of n for the first part, and of log n the second part. We can usually when we're doing time complexities, we don't usually say 2, so this is basically the same thing as saying of n log n. So this is the time complexity of the merge sort. Okay, let's now write the code for let's write the first part, which is this part that we first did. Let's call that function merge sorted array. It's gonna take 2 arrays, array 1 and array 2, that are already sorted. We're gonna first declare some variables, and 1 to keep the index of the first array, and 2 keep for the index of the second. We're gonna have a result array, which will be empty at first, and we're gonna have the length of the result array, which will be 0. Next, we're gonna have a while loop. We're gonna go while n minus 1 is more than the length of the array 1 does, and we're gonna go n2 is less than length of array 2. And to the result index of k, we're gonna add whichever is minimum, whichever is the smallest element, array 1 of the index n1 or array 2 of index n2. And if we said that array 1 of index n was smaller than array 2 of index n2, then we're gonna, because we used an element from the array 1, we're gonna increment the index. And now we're looking at the next element, because we just used the first one. We're gonna look at the fixed element. Else, we're gonna do n2, because that means that we used the one in the n2. The element in the array 1 wasn't smaller, then the element in the array 2 is smaller. And after we do this, we're gonna have another loop, another while. We're gonna do while n minus 1 is less than length of array 1. So if we have elements left in the n minus 1 after we if we combine both of the arrays, and if we still have elements left in array 1, we're just gonna add them to the result, k++ and n++. Obviously at the top we're also supposed to do k++ after that. Okay, so and we're gonna do the same thing for array 2. If we have elements left in array 2 after that, not array 1, then we're gonna do it for array 2. Same thing, ok equal error 2 n2 k++ and n2++. This should be m1. Okay, at the end we're gonna return the result array. It looks pretty long, but I actually took a lot of space. Should be shorter than yeah. Now I'm gonna write the second part, which is gonna be the second part that we just did here. This was combining the sorted arrays, and now we're gonna divide it into smaller arrays until there's only one element. So let's call that merge sort. This is gonna be shorter. Let's call that sort. It's gonna take array. If array is size equals 1, array that size is 1, turn the array. And we're gonna do, if that's not the case, we're gonna find the midpoint, which is array height or length, whatever you want to say, it's the same thing, divided by 2. And we're gonna have two different arrays. Left, which will be an array from the element 0 or 1, whichever you start with. It's going to be an array. It's going to be an array from the element 0 to the midpoint. And we're going to have the right side, which will be also an array from midpoint till the end. And we're going to keep doing this. We're going to keep dividing. So we're going to do left equals merge sort, and same with right. And so we're going to keep doing this recursively, which means that we're going to keep dividing until it equals 1. And then we're going to make a new array called merged array. And we just created that function, so we can call that function that we just created before this. We called that merge sorted array. It was right there. Right at the top. It was called merge sorted array, and we will add the left and the right, which at first will be only one single element, and we will get, so we're gonna left sorted array and then the right sorted array, and then lastly we can return the merged array, and then we'll be done. So now let's take a look at this. With the actual Java code. So right here, the red, the part that I wrote with red is right here, where we declare the functions. And the part that I wrote with blue is right here, where we went through, we checked the first elements. We keep checking the elements and comparing them, and then combining them in the result. The part I wrote with green is right here, and lastly the part that I wrote with purple is here, and the last the return. So when we're in the green loop, we're basically continuing keep adding the elements until we exhausted all elements in the first array or in the second array, until we have no elements to look through in the first array or the second array. And so if one of this is true, we're gonna keep going. We're gonna be done with that loop, and we're going to enter the loop in the green if we have elements that we haven't gone through in the first array. And if we don't have it, we're just going to skip to the next loop, and which is the purple one. And the purple one is checking the same thing for the second array if there's elements that we haven't checked yet. And it's going to keep adding to the result because they're already sorted. And then we're going to return what was the time complexity of this function. It was of n. Okay, now let's move on to the next. And here we have the second function with the black right here. We have we're first checking if the array length is 1, and if that's not the case, we're just gonna move on to the part where I wrote in red, which is right here. This is the part where I wrote in blue. Okay, so if we go back, the purple part is the condition that we checked. It's important. That's where we stop the recursive function. That's the base case for our recursive function. The red part is where we keep dividing and dividing until we're going to divide into left array. We're going to find a midpoint, middle of the array. We're going to divide into left and right. We keep dividing until it's only one element, which means that it's sorted. One element means it's sorted. With the blue circled place, we're going to just sort left and right. We're going to call the function that we just coded up above, right here. The time complexity of this whole algorithm, which is called merge sort, is O n log n. And that's it. Thank you for watching.